In this video, we're going to talk about applications of functions. So let's go through the first example. I'll give you a couple of seconds to read the problem. Okay, let's take a look at part A then. It says calculate the median salary with 7 years experience. Since the years is represented by x, this will be x equal to 7. So that means it's going to be f of 7 is equal to okay, so let's multiply. And add them together. Okay, so let's write a summary sentence to describe what we just determined here. Okay, let's do the next example then. So now we want to know how many years of experience is required to have this median salary. So this is going to be f of x equal to the salary here. So put it in. All right, so let's solve the equation for x. Divide both sides by 1343. We get 11. So let's write a sentence to summarize. Okay, so let's take a look at part C then. We want to write what the slope and the y-intercept mean in the context of the problem. Well, the slope is 1343, which is the same thing as 1343 over 1. So two things we're comparing here, years and increase in salary. Okay? So for every 1 extra year a person works, they should get a $1,343 raise. So let's write that out. Okay, the y-intercept is 45,657. Remember, that is an ordered pair. And the 0 means years. And the f of x is salary. So let's write a sentence to summarize what this means. The starting salary of a network system and data communication analyst is $45,657. Okay, so let's take a look at the next example then. So here we're talking about two different teachers, the years of experience and their salary. Okay? So we're talking about writing a linear equation S that represents the salary of the teacher in terms of the number of years of experience y. So the function name is S of y. So when we write out the function, that means the years is the domain and the salary is the range. Now, I should be able to write out two different ordered pairs for this. One ordered pair would be this, and the second ordered pair would be this. So, in order for me to write this linear function, I need two things, the slope and the y-intercept. So let's calculate the slope first. So this gives us 11,000 over 5, which is the same as this. Now, we need to calculate the y-intercept. So we need to pick one of the ordered pairs. So I'm going to choose this ordered pair. So I'm going to use slope-intercept form. Okay. We solve for b. Okay, so now we know what the y-intercept is and we know what the slope is. So now we can finally write our linear function, so s of y. So remember, the variable here is y because that's what the domain is. So here's our linear function. Okay. Part B, what would you expect the salary of a teacher with 20 years experience? So this is y equal to 20. So s of 20. And this will simplify as this. So 79,000. So you would expect a teacher's salary to be $79,000 when they have 20 years of teaching experience. Okay, let's do part C then. So now we're talking salary, so that is now going to be S of Y is equal to this salary. And we want to solve the equation for Y. So in this case, we would expect a teacher to have 30 years of teaching experience in order to get this salary of $101,000. So what I would do right now is pause the video and I would write a sentence that describes both situations in part B and in part C. Okay, last part we're going to do with this, we want to be able to interpret the slope and the y-intercept for this problem. So I'm going to rewrite what the slope and the y-intercept are now. Okay, so the slope can be rewritten as what? 2,200 over 1. This talks about salary. This talks about years of teaching experience. So, in other words, every extra year a teacher has of teaching experience, his or her salary should increase by $2,200. So let's write a sentence to summarize that. A teacher's salary should increase by $2,200 per year. Okay, the y-intercept, I can write this as an ordered pair. Again, this is years of teaching experience, and that's a salary. So in other words, a teacher's starting salary should be $35,000. So let's write that out.